Okay, hello. This is my video for today's check-in. It's check-in number 12. So since the last check-in, I think I've probably spent around 10 hours working on this course. So far, right now I'm working on Chapter 17, trying to get ready for our Chapter 17 quiz and the upcoming test. So I've watched the first couple videos that you've provided for us for chapter number 17, talking about energy and momentum. So I just finished up the video that talked about energy and then some of the examples that dealt with that. So similar to what we've been doing in other sections, this is kind of an extension of what we did in chapter 13, moving along to rigid bodies and applying what we learned in chapter 13 to a rigid body, kind of extending that. And because of that, we have the rotational components that we have to account for. And so, for example, in the kinetic energy equation, we had T equals 1/2 mv squared, which is the translational part. And now we've had to add on a term that is 1/2 I omega squared for the rotation. And then similar to chapter 16, we can use the parallel axis theorem with that term depending on where the center of rotation is. I've also spent some time reading through the textbook in chapter 17 and looking at the problems. It starts out by just kind of explaining what we had learned before in chapter 13, and then, like I say, extending that. So it has the equation where T1 plus U from 1 to 2 equals T2, and then we can break down each of those terms and see which additional terms we have to add now that we're looking at a rigid body and not just a particle. Something interesting I learned from your videos and the textbooks that was a new concept to me was the torsional spring, which is a potential energy. So we had dealt with potential energies of a spring before in physics and in chapter 13, but those were linear springs that stretch linearly. And so for a torsional spring, it's a spring that has like a moment to it, or I like to think of like a watch spring that's wound up. And so instead of the equation for a spring that we're used to, we have the distance theta that it changes. So the equation is 1/2 k theta squared. And the k term has different units than that we have to watch. And so I thought that was kind of an interesting concept. I've never worked with those springs in problems, and it's kind of interesting to learn about that. Other than that, this week I've started doing some of the sample problems in the textbook for chapter 17. So one of them had to do with a weight that was suspended by a wheel, and then the other one was some gears, and it just kind of helped me to start applying these concepts and learn how energy is different for a rigid body than it is for just a particle. And for the homework, so far I've completed the first 2 problems, but I hope to get a couple more of those done tomorrow, and watch a couple more of your videos to go along with that. So I'm hoping to start going into momentum more. The last thing I was looking at was the power term, which was kind of interesting in your videos, and then in the textbook it talks about power and how it equals m omega, and how that's different than the previous power that we used, which was force times velocity. And so it'll be interesting to apply that term in the problems as well, as we have that moment term. But that's it so far for this week. So far, I think Chapter 17 is going well. I feel like I understand the concepts pretty well. They're a little more complicated than what we saw in Chapter 13, but it's a good extension. I think I can understand the differences in the equations and where it's coming from. So, but that's all for this week. Thanks for listening.